Lesson 116, solve simple and compound interest problems. First off, simple interest problem. Simple interest means if you open up an account at a bank, the bank is going to pay you a certain percentage for them to have your money in their bank. And so they usually pay you once a year. So that would be an annual interest. And so it would be a percentage amount based off of what you first put into the account. So if you look at the formula right here, I equals PRT. I is the interest you earn, and then the P is the principal, so the original amount that you invest into the bank. The R is the interest rate the bank is going to pay you to put your money into their bank. And then T is the time. How many years are you going to be putting your money in there? And so the time has to be in years. They give it to you in months, you got to convert the months to years. Let's take a look at an example here. An account is open with $5,600. The bank pays 4% simple interest annually. How much interest will be earned in 10 years? So I use the formula I equals PRT. So I need to find the interest earned. The principal, the original amount is $5,600. The interest rate the bank is going to pay is 4%, so I need to put that as a decimal, so 0.04. And then the T is 10 years. And so if I grab my calculator out, I can solve this one. So I do 5,600 times 0.04 times 10. So that would be $2,240. So that's the interest earned. So $2,240 would be how much the bank will pay you to put your money into their bank if you start off at $5,600. Second example, the same type of problem. This time we want to know how much it will be in the account, not how much they're paying you, but how much is going to be in the account after 12 years. So I'm going to use the same formula, I equals PRT. So the interest earned, we need to know how much are they going to pay you each year. So I need to find that interest earned, but you're putting into the bank $25,000 this time, and their bank is going to pay you 6%, so 0.06 for 12 years. So if I get my calculator out again, so 25,000 times 0.06 times 10. Actually, that shouldn't be times 10, it should be times 12 for 12 years. Hit enter, says $18,000. That's how much the bank is going to pay you to have your money in their bank. So how much is your account going to be worth after 12 years? Well, you start off with 25,000. The bank paid you 18,000. So that would give you a total of $43,000 that you would have in your account after 12 years. 1C, this one we're trying to find how many years was the money borrowed. So you're going to use the same formula, but instead of finding the I, we're going to find the T. So I equals PRT. So the initial amount borrowed that you're borrowing, so that's your principal amount, is $4,500. They're going to pay you at 2.5%, so that's 0.025. We don't know the time, so we're finding T, but the bank paid you over that time period $562.50. If I do 4,500 times 0.025, that's going to give me $112.50 equals the $562.50. To get T by itself, I just need to divide by 1250. I come back to my calculator. We'll do $562.50 divided by $112.50 gives us a total of 5 years. That's what the time would be. have that account open for. Example D, now we're finding the interest rate. The same formula, but this time we're trying to find the R. And you notice that this says 15 months. So I need to convert 15 months to years. So I would just take the months, divide by how many months in a year. There's 12. Divide by 3/3, which gives me 5, be 5/4, which that would be 1.25. Okay. So 1.25 months or years, 1.25 years. So my interest earned was $130. I invest $2,600 at an interest rate I don't know, but I know that I'm doing it for 1.25 years. Now if I come to my calculator, we have 2,600 times 1.25 gives you 3250. 3250R equals 130. Divide this by 3250. Divide this side by 3250. Your interest rate. And now when we do this division, they're going to give you the percent as a decimal. So you need to multiply that by 100 afterwards. So we have 130 divided by 3250. And that gives you an answer of 0.04, which means 4%. That's how much the bank is going to pay you for you putting your money into their bank. Second type is compound interest. Compound interest is different than simple. Compound interest, they pay interest on the principal, the amount you put in, plus any interest that you earn. So the more you put in, the more interest you earn, the higher and quicker your money builds. Simple interest, they only pay interest on what the original principal. So the original amount you invested, that's how much. So it's going to stay the same every year. But compound interest, the amount that they're going to pay is going to increase because you have more money in the account. And so it's more on what's in there plus the interest earned. So the formula you can see right here is the account amount equals P principal times 1 plus the R over N. R is for the interest rates, N is for the number of times they're going to pay your account. And then times NT, raised to the NT power. Just to let you know, for N, if it's annually, that's 1 time a year. If it's quarterly, that's 4 times a year. So let's take a look at an example. So $12,000 is invested at 4% compounded annually. Find the value of the investment after 30 years. So annually means it's just 1. So you can see the simplified formula for that one is, we want to know how much is in the account when the principal is $12,000. They're going to pay 1 plus 4%, which is 0.04 for 30 years. I got to raise it to the 30th power. I come to my calculator. I have my $12,000. I'm going to multiply that by 1.04. And I'm going to raise that to the 30th power because that's for 30 years. That gives me $38,920.77. $38,920.77. That's how much would be in your account after 30 years when you invest $12,000. Next one is the same type. The only difference is quarterly. So now you can see our formula where you have an N, you're going to put the 4 in there. So I need to find out how much my account is worth when I stick in $12,000 in the bank for 1 plus 0.04 divided by 4 raised to 4 times 30. So when I do this, let's get our calculator back out again. We have the 12,000. We're going to multiply this by parentheses 1 plus, okay, I'll go back here. So multiply this by parentheses 1 plus 0.04 divided by 4 in parentheses. And then we're going to raise that to, it's going to be the 120th power. That's going to give you $39,604.64. So $39,640 and $604.64. That's how much would be in your account after 30 years if they were paying you interest 4 times a year. You can see it's a little bit of an increase the more they pay the interest a year. Example 3A, comparing simple and compound interest. So here it says an account has $2,500 and 12% simple interest. Complete the table to find the total amounts in the account after 1 year, 2 years, 5 years, and 10 years. So I need to use I equals PRT. So you are investing $2,500 for 12%, so 0.12, and you're doing that for 1 year. When you do that, you end up with $2,800. So here in here you just put your work, which would be 2,500 times 0.12. You have a total of 2,800 in your account. But if you were to figure out how much interest would be paid, you would do your 2,500 times the 0.12 times the 1 gives you your 300. So you're adding 300 to what you originally had. So that gives you a total amount of 2,800. Now the second, for 2 years, you still have your 2,500 plus. So now instead of the 1, we're going to put a 2 here. So come back to our calculator. So I have my 2,500 times the 0.12. This time times 2 for 2 years. So that's going to be 600. 600. So now that will give me 600 plus 2,500, which will give you $3,100. You'll notice that each year is adding $300 to it. So 2 years is 600. If I multiply the 5 by 300, that's $1,500 right there that I'm adding to it. So 2,500 plus 1,500 gives you a total of 4,000. And then if I'm multiplying 10 times 300, that's 3,000. So 2,500 plus your $3,000, which will give you a total of $5,500 after 10 years. If we were to do the same thing, but this time it's going to be compound interest, we're going to do the same thing, but we're going to compound it annually, so 1 time a year. So I'm just going to use this formula that they have here. So it's going to be 2,500 times 1 plus the interest rate, so it's going to be 1.12 times 1 for 1 year. I come to my calculator. I got 2,500 times 1.12 raised to the first power equals $2,800. So that's how much you're going to have in your account. So $2,800. Because remember, they're going to give you the total amount at the when you're using the compound interest formula. It's going to tell you what you get at the end of your years. So what the total amount is. And then if I go to the next one, so if I do 2,500 times 1.12, and I'm going to raise this to the second power for 2 years, that gives me 3136, which is already more than what I had for the simple, because the simple one would have been 3,100. So we're $36 ahead already in the first year, second year. Now if I do 5 years, so take my calculator, do the same thing, 2,500 times 1.12 raised to the fifth power, that gives us 44,405 and 85 cents. 4405. 0.8484 cents. Now if I do it for 10 years, grab my calculator again, clear this, so 2,500 times 1.12 raised to the 10th year, that gives us $7,764.62. The second was 85 cents. So $7,764.62. You can see you gain more when you are using compound interest than you would with simple interest. Now what I want you to do is take the amounts from the last two slides and create a graph to show how the growth of the two accounts occur. Here you can see an example of a different problem, how compound was more of a exponential function, as it starts here and then all of a sudden it goes steep. The other one, the simple, is linear because it stays the same every year. They pay the same amount. Now let's go through an application. Two people plan to retire at age 65. A 25-year-old woman invests $2,000 in a bond that pays 7% per year compounded annually. A 45-year-old man invests $5,000 in a bond that pays 7% per year, also compounded annually. Whose investment will be worth more when they reach retirement age, and by how much? So let's do the 25-year-old. So the 25-year-old, since it's compound annually, so it's just one time, so I use A equals principal times 1 plus the rate raised to the t power. So how much will their account be if 25-year-old invests $2,000 at a rate of 7%, so that's 1.07, and she's going to retire at the age 65. So 65 minus 25 would be 40 years. So for 40 years, I get my calculator out. So we have $2,000 times 1.07 raised to the 40th power. Gives us an answer of 29,948. 29,948. 29,948 dollars, and the amount of cents would be 92 cents. That's how much she would have when she would retire if she gets that amount. The other one, 45-year-old, he invests 5,000. So A equals P times 1 plus the interest rates times the T. So how much would his account be if he invests $5,000 at an interest rate of also 7%? but he can only go, so 65 minus 45, he's only doing it for 20 years. I come to calculator, so you got 5,000 times 1.07. Raise that to the 20th power. That gives us 19,348.42. So 19,348. And that would be 42 cents. So who's worth more? A 25-year-old is worth, her amount is worth more. And it's by how much? So I'm going to take my two amounts and I'm going to subtract the two. So I'm going to take 29,948.92, subtract 19,348.42, gives us $10,600.50. 10,600 $10,600.50. That's the difference. You can try the second application problem yourself for extra practice. Otherwise, your assignment would be lesson 116, numbers 1, 6, 10, 12, and 19.